Good evening, ladies and gentlemen. This is your well-rounded math teacher, Mr. Picard. We're going to talk about arithmetic series. It's Unit 11, Video 3. Arithmetic series are two learning targets. You can find sums of arithmetic series, and I can use sigma notation. First thing here we have, it says series. Suppose a section of an amphitheater can seat 11 people in the first row, and each row can sit 4 more people than the previous row. Find the number of people who could sit in the first 5 rows. Okay? The first row, we can sit 18 people. Second row, we're going to add 4 to that. That's 22. Third row, 26. Fourth row, that'd be 30 if you add 4. And finally, the fifth row, we can sit 34 people. Now we want to find out how many people. Now this is a sequence here. It's arithmetic sequence because we're going up by 4 as our first term is a sub 1, which is 18. But we want to add all these up. So the sequence now turns into what we call a series. A series is when we take a sequence and add all the terms together. So a series, you're going to see addition in between all your terms. So for this particular series, adding up these first 5 rows, we get a total of 130. The total is what we call S sub n. That's the sum of a series. A couple other things. Your first term is still a sub 1. Okay? Second term, our 22, would be a sub 2, a sub 3, so on and so forth. What you have to get used to, and it's new for series, is this. Your last term, which would be a sub 5 here, we're going to call a sub n. A sub n is always your last term. A sub 1 your first, a sub n your last. And when you see this S sub n, you know they're talking about a series. They're talking about taking a sequence and add all the terms up. So, yes, this is a sequence, but when you see the addition in there, we call it a series. Arithmetic series is what we're going to work with today. There's a couple different formulas here. You can see what I talked about earlier, S sub n. The sum, S sub n, right here, of the first n terms in arithmetic series is given by these two formulas. The difference, the second formula is a little bit easier to work with. All you need is 3 things. N, you can see n right there. The first term and a sub n, which is the last term. That's one thing we got to get used to it. Last term. In the first one here, we have a sub 1. You're actually multiplying it 2. We have n right here and we have n right here again. So you're going to need n for both of these formulas. The difference is the common difference, d. For the first series, S sub n, you need the d. In the second one, you don't need d, but you do need the last term, a sub n. So it depends on what you're given, which formula you're going to use. If you have everything, the most common one people use is this second one because it's a little bit easier to use. Okay, here we go. Find the sum of the first 100 positive integers. Well, looking at that, the first 100 positive integers, that's 1, 2, 3, 4, so on and so forth. All the way up to, let's look at the last 4 terms, 97 plus 98 plus 99, and finally plus 100. We're going to use this second formula right here. S sub n, the sum of your series, equals n over 2. And we know what n is. It's the first 100 positive integers, so n is going to equal 100, times a sub 1 plus a sub n. Okay, why does this formula work? Just to give you a little bit of background on this. Here it says take a sub 1 and add it to a sub n. 1 plus 100. Well, 1 plus 100 equals 101. There's a pattern here. Now take the second term and the second to last term. If you add those, 2 plus 99, you're going to get the same thing, 101. 3 plus 98. You're going to get 101. How many of these are you going to get? Well, if you take the first and last and go on and so forth, so on and so forth from there, second and second to last, you'd have 50 different addition problems here. So that's kind of why they say take the number of terms and divide it by 2. 100 divided by 2 is 50. And multiply that by the sum of the first term and the last term, because that's going to be the same as all those other sums. So, plugging in what we know. S sub n is going to be 100, because n is equal to 100, 100 terms over 2, times a sub 1, which is 1, plus 100, which is our last term, a sub n. This is going to equal 50 times 1 plus 100 is 101. 50 times 101 is 5,050. So the sum of your first 100 positive integers is 5,050. And that's a little bit of the background of this formula right here. Series formula, arithmetic series. Okay, what do we got here? We got our two formulas again. Oh boy. Aiden did push-ups every day in March. He started on March 1st and increased the number of push-ups done each day by 1. He did a total of 1,085 push-ups for the month. How many push-ups did Aiden do on March 1st? So what we're looking for here is basically a sub 1. We're going to use one of these series formulas to help us find a sub 1. So we need to talk about what we know. March, first of all, that's going to give us the number of days. There are 31 days in March. I don't know a sub 1, that's what I'm looking for. I know S sub n. I know the sum of all these push-ups is 1,085. How many push-ups? What else do I know here? Oh, I know this. He increased the number of push-ups done each day by 1. So our common difference is 1. And this is all we know. I don't know a sub n or a sub 1, so that's not going to help me. I know n, I know d, so I think if we use this first formula, plugging 1,085 in for S sub n, or the sum of the series, we should be able to solve for a sub 1. So using that first one there, 1,085 for S sub n equals n over 2 right here. So it's going to be 31 for n over 2. 2 times a sub 1, we don't know what the first term is, that's what we're trying to find, plus n, which is 31, minus 1, times the common difference, which is 1. There we go. So if I solve that, I'm solving for a sub 1. So there's more than one way you use these formulas. Most of the time you're trying to find the sum of a series. So you're trying to find S sub n. This time we're trying to find a sub 1. So just simplifying this down and trying to solve here. 31 divided by 2 is 15.5 on your little calculator. 2 times a sub 1. This is going to give me 30 times the 1. So that's just plus 30. Now we're going to use the distributive property. So 1,085 equals 15.5 times the 2 is going to give me 31 again, 31a, plus 15.5 times 30 is 465, I think. And all we have to do here is subtract 465 and divide by 31. Subtracting 465 I get 31a equals 620. Divide by 31. Looks like a sub 1 equals 20. What does that mean? On the first day in March, a sub 1, he did 20 push-ups. There we go, a sub 1. So a different way of using that formula. The radio station is giving away a total of $124,000. Cities 97, sweet station. In August, if they increase the amount given away each day by $100, how much should they give away the first day? Okay. Well, this is how much money they're giving away altogether. So if you take, well, in August now, we'll start out with n equals 31 again. I think August has 31 days in it. And S sub n, the sum of all the money given away each day is going to be 124,000. So we're kind of doing the same thing here. And also our common difference, not 1 this time, but they're going to start out by giving so much money away the first day, and they're going to add $100 each day after that to give away. So our common difference once again is $100. So we're going to use that same formula right here. I know the common difference is 100. I know n is 31. I don't know a sub 1, that's what I'm trying to find. And I do know S sub n is 124,000. So, plugging it in and solving. 124,000 for my S sub n, sum of the series. Equals n over 2, which is 31 over 2, times 2 times a sub 1, plus, again, 31 minus 1. And our common difference this time is 100. So, simplifying it down, 15.5 to a sub 1. This is going to be 30. 30 times 100 is 3,000. Okay. So doing the math here, using the distributive property, that's going to be 31a sub 1 again, our first term. 3,000 times 15.5 right here is 46,500. Okay, so subtracting 46,500 and dividing by 31. Again, if I subtract 46,500 from both sides, this will be gone. 31a sub 1 equals 77,500. Divide that by 31. 31. A sub 1, our first term, is going to be $2,500. What does that mean? In the first day of August, August 1st, they gave away $2,500. That's our a sub 1. You could find a sub n using one of the other formulas too. Okay. The sum of all positive odd integers less than 180. The sum of all positive odd integers less than 180. Okay. Positive and odd. Well, first positive odd integer is 1. Next one is not 2 but 3. 5, 7. You kind of get the idea. 179 would be the largest, so let's go 175 plus 177 plus 179. Just so we have an idea of what we're working with, so we can kind of figure some things out. We could use either one of these two. I think we know everything here. We know a sub 1 is 1. We know a sub 2. Oh, I don't want a sub 2. Sorry about that. I want the last term. A sub n is 179. Our common difference here, some people get a little confused with this, but what are we going up by every time? Difference between 3 and 1 is 2, between 3 and 5 is 2. Our common difference is just 2. The only other thing I need is n. Well, basically we're taking half of all the terms less than 180. Half of 180 is 90. There's 90 terms here that we're working with. I would say probably the easiest formula to work with here. You could put it in the first one, we have everything. I'd use the second one. So the sum of our series, S sub n, is 90 over 2, n over 2 basically. A sub 1 is 1 plus a sub n. Oh boy, what do we got going on here? Okay, little glitch there, but we're back in business. 179. This is n, a sub 1, a sub n, our last term. So 45 times 180. 45 times 180, you should get 8,100. I'm sorry, yeah, 8,100. That's what S sub n equals. That's the sum of all the terms in this series. And once again, a series is just a sequence, but you're adding all your terms together. Okay. Okay, this one's a little bit different. A little difficult, but I'm going to walk you through it and show you can use these formulas basically in a little bit different way. It says find the first 3 terms in an arithmetic sequence. A sub 1 is negative 16. A sub n, my last term, is 33. And the sum of the series is 68. Okay, we need to find the common difference. So you would think you'd use this formula here. But the key is we don't know n either. We don't know how many terms they're working with in this particular series. So what I can do is this. I know all the terms in this formula except n. So if I plug in a sub 1, a sub n my last term, and s sub n down here, I can find n. Then once I find n, I can plug n into this formula and everything else that I know and solve for the common difference d. And then once I find my common difference, I can find the next 3 terms in this arithmetic sequence. So there's a little bit of work going on here, but this is one way to do it. So using this formula here, we get 68 equals n over 2, which I don't know n, negative 16 plus 33. And from here, we're going to be doing some solving. So, first of all, 68 equals n over 2. Negative 16 plus 33, negative 16 plus 16 is 0. I'd say that is 17. But I'm going to say 17 over 1 because I have a fraction. So what I end up with here is 68 equals, multiplying these 2 fractions, first of all, n times 17 is 17n. And 1 times 2 is just 2. How am I going to solve this? I would think multiply both sides by 2. Get rid of your fraction here. These cancel out. And I get 136 equals 17n. Divide both sides by 17. N equals 8. So from all that, I got n equals 8. We solve for n. So you can use these formulas for other things than just finding the sum of a series. Anyway, now I'm going to bring this down because we're going to use that formula to do a little work. I know this. All this information right here, a sub 1, a sub n, and the sum of the series, and now I know 8. But what I really need to know is find the common difference. So we can use this formula because we have everything we need to know in it except the d, and we can solve for d. So sum of the series is 68 equals, n is now 8 over 2 times 2 times a sub 1. A sub 1 is equal to negative 16 plus 8 minus 1 times d. Okay. So doing a little bit of work here. This is equal to 4. Negative 16 times 2 is negative 32 plus 8 minus 1 is 7, and 7 times d is just 7d. Distributing our 4 through the quantity, I'm going to get, first of all, 68 equals negative 128 plus 28d. Adding 128 to both sides, I'm going to get 28d equals I think it's 196. Dividing both sides by 28. D equals 7. So my common difference is 7. So I know this. A sub 1 equals negative 16. So a sub 2, a sub 3, and a sub 4, the next 3 terms are what we're looking for. If I add 7 to negative 16, I get negative 9. If I add 7 to negative 9, I get negative 2, and then finally 5. What are the first, find the first 3 terms? Oh, if we just wanted to find the first 3 terms, those would be the first 3 terms of this series, or sequence. Okay. What else do we have here? Oh, summations. Okay. This little guy is pointing to this symbol right here. This is a symbol you will see in calculus and a lot of other classes. This is sigma, and it means to add. What do we add? Well, sigma notation, another term for it is a summation. Okay? Summation means you generate some terms and then you add them all up. Here's how you work with this sigma or these summations. You're given a number that you start with. The first number we're going to start with is 1, n equals 1. And we're going to go all the way up to 10. We're going to plug in numbers all the way up to 10. And for what? This little expression right here, 3n. So the first term, a sub 1, I guess you'd say, would be 3 times 1, or 3. Second term, that means we're going to plug in 2. You count up by ones. That's 3 times 2, or 6. Third term, 3 times 3 now. That's going to give me 9. And we're adding all these terms together. Fourth term, plugging in 4, pretty easy. 3 times 4, and that's 12. All the way up to, here's what I usually do with these, with sigma. I just generate the first term and our last term. Last thing we're going to plug in is 10. And that's going to give me Well, the 10th term, we're plugging in 10 for n. That's 3 times 10. 3 times 10 is 30. So, adding up all these terms. Now, you more than likely could generate all these terms, and that would be fine. And then just add them up by hand. You can do that. But I'm going to use this formula right here. I know the first term, a sub 1. I know the last term, a sub n, which is 30. And how many terms are there? Well, it's pretty obvious. There's 10 of them. Now, well, we'll get to the next one in a minute anyway. So, plugging in everything, s sub n equals n over 2. That's 10 over 2. First term is 3. Last term, a sub n is 30. So this is 5 times 33, or 165, I think it is. Yeah, 165. Now once again, you could have just generated all these terms, filled in this gap here, 5, 6, 7, 8, 9, all the way up to 10, and just added them up. I usually just generate the first term, the last term, and figure out what n is. It's not as easy as you think it is. This was starting at 1. It's always easy when it starts from 1 and goes to whatever. If this would have been 15, then n would have been 15. But you're going to see in the next one, it's not so easy. Anyway, sigma. That's the main thing with sigma. You're just generating terms and then adding them all up. It's a summation. Sigma. Okay, this one's a little bit different. Not a lot different, but a little bit. Sigma notation, summative or summation, some people call it. Here's our expression that we're going to plug in numbers for and generate our terms. But now we're not starting with 1, now we're starting with 5. So that just means you plug in 5 first. So if I'm going to plug in 5 here, this is going to be 3 times 5 minus 1. 15 minus 1 is 14. There's my first term. Then I plug in 6. 3 times 6 minus 1. That's 18 minus 1, or 17. 7. 3 times 7 minus 1. That's 21 minus 20. 21 minus 1 is 20. You can see my common difference is 3. That's because you're multiplying by 3 every time. It doesn't matter what you add or subtract. You're multiplying by 3, so your common difference should be 3. 5, 6, 7, and then finally 8. Well, that is 3 times 8 minus 1. That's 24 minus 1, or 23. So these are the 3 terms that you would add up. And you should get 74 when you add them. Now, there's only 4 terms to generate here. If you had to generate like 50 terms, you're not going to generate all 50 terms. You could, but I would probably just get your first term. This is still a sub 1. Even though we started with 5, it's still my first term. This is still a sub n. Okay? Now, the other term that we have to find here, if we're going to use that second formula, is this, n. Even if we're going to use the first formula, we'd use n. Now you can see that we have 4 terms here, but what a lot of people do is they'll take the last term on top and subtract this term, 8 minus 5, which is 3. They'll say, oh, n's got to be equal to 3, which is wrong because you have 4 terms. What you have to do when you're subtracting like this is, yeah, 8 minus 5 is 3, but then add 1 to it every time. So n is equal to 4. You have to be careful with that. To get you to understand this a little bit, look at here. N was equal to 10 because we went from 1 to 10. But if you're going to figure it out by subtracting, 10 minus 1 is equal to 9. You still have to add 1 to it to get actual n equaling 10. So if that's how you generate your n, is subtracting these two numbers, make sure you add 1 to it to get your actual n term. And s sub n would equal 4 over 2 times 14 plus 23. You're still going to get 74 for an answer. And that is all she wrote. Enjoy your worksheet. Peace out without a doubt.